All right, so this is the second half of the lesson. Unfortunately, I hit the wrong button, and so I just had to make 2 separate videos and wasn't able just to make one complete lesson. So what we did in the first half was define what are Newton's 3 laws. What we're going to do now is take a look at these 4 examples and determine what law is being applied based on the description we're working with. So in this first example, we have this individual who's on like a metro or a train, and you can see that at step 1, which is all the way on the right-hand side, it's number 1, that the train is in motion. And so the train begins to slow down and applying the brake. And so there's an apparent force on the passenger which causes them to move forward. And when it comes to a complete stop or comes to a halt, you really feel that forward motion. So what we have going on here is that this person's body is acting no different than kind of in a car accident, that it's in motion and it wants to stay in motion until an outside force is applied. And so by holding onto that handle, they're able to generate a force to bring their body to a stop. So what we're experiencing in example 1 is Newton's first law of motion. Again, why? It's showing that a person wants to stay in motion. So they want to stay in motion as the train slows down. Okay. The next example shows a car and a rock or pop can. I'm not really sure what they're showing, but something that has small mass, but a large acceleration. They're showing that the car has a large mass, small acceleration. So again, we can say that this can or rock, whatever it is, has less inertia. The car has more inertia. But on the left-hand side, it shows that they're generating the same amount of force being applied. So because the same amount of force is being applied, we can get more acceleration out of an object with less mass, less acceleration out of something with more mass. So that's talking about force, mass, and acceleration and how they're all interrelated. So that's applying Newton's second law. And so again, for application or the explanation, it's showing the relationship between our mass and acceleration when a force is applied. Okay. I have 2 more examples for us to take a look at. And so here we have an individual that kind of the left-hand side, the picture is kind of a before, and the right-hand picture is an after. And let's say maybe a ball rolled out into the street and they had to come to a sudden stop. And so they moved forward and then would continue to move forward if the seatbelt didn't act against them. So this is another example showing Newton's first law of motion. So what it's showing is that the person would continue moving forward if the seatbelt didn't stop him. Okay, and then the last example, we have this cannon that's lit and an explosion happens and we are able to launch this cannonball from it. So we see that because of the launch, we know the cannon is going to roll backwards, but the cannonball is going to be accelerated forward. So this is action-reaction. And so that's Newton's third law of motion. And so again, it's showing the action-reaction. Between cannon and cannonball. So your homework is going to be doing essentially this. You're going to look at an example and determine which law is being applied. So you can access the notes from the previous component, and looking at these four examples, you should be able to determine what is going on in terms of which law is being applied.